No, just twice.
Hi, everyone. Hello.
Okay, you're making fun of the car.
All right. Hi, everyone. Welcome to the ERC workshop. So has anyone here visited the ERC before? Knows about the ERC? Okay, not many people. So a little bit about the ERC, we're the Critical Reasoning Center. We support the college with anything really data related, whether that's manipulating data, analyzing it or visualizing it. So today we're going to be working with Stata specifically. And that's a programming language used to work with data and do a lot of statistical analysis. Has anyone here used Stata before? Oh, 2 people. All right. So we're gonna walk through it slowly. I'll provide you the code. And if you have any questions at any point, please feel free to stop me. I'm not here to grade you. So, if you have any questions, please ask them. If you have a question, it's very, very likely that someone else in the room also is curious about the same thing. So please go ahead and ask your questions. And this is the link to access the files. You can either use the QR code or the tiny URL. So I'll just wait for folks to pull it up. You don't have to follow along if you don't want to. You can also just watch. That's also perfectly fine. It's really up to you, and however you learn best, you can kind of decide what you want to do. I'm also recording this session, so it will be available to you all after. So I'm also going to navigate to this website so I can also download the files. And it will take you to this GitHub page. And on the GitHub page, all the way on the right-hand side, you should see these 3 dots. So then you can click on it and press download. It is going to download what is called a zip file. So for many of you, you probably use a Mac. So Mac kind of does this automatically, where as soon as you click it, it'll unzip the files. But on a Windows computer, what you have to do is once you click on the file, you have to explicitly then press the button that says extract all. So does everybody see the extract all button? Okay, this is really important because you can't use the files. Even though you're able to see them, you're not able to use them unless you extract them first. So just make sure you press extract all. And you can let it do its the destination that it defaults to. So now you should have 2 windows. And the way to tell the difference between which one is the zipped one and which one is the unzipped one is that up here in the icon, one of them will look like a regular folder and one of them will have a little zipper icon on it. And again, just to repeat, so for whoever's following along, first go to the URL, and then it's the 3 dots, and then press download. Right, and then I clicked on the file. If it disappeared for you, obviously you can get back to it by just going to downloads, and then there's my zip file. And I pressed extract all. Okay. By the way, if something's also not working on your computer, you can also feel free to raise your hand and I'll come over and look up. Yeah. Sure. It's tinyurl.com/ERC Stata. Yeah.
There's the extract all on a Mac.
So on a Mac, it should automatically extract. You'll see if when you open the folder, does it look like a regular folder icon, or when you're looking at it in the downloads, does it have like a zipper on it in terms of like the image of the folder?
It looks like regular.
So you should be fine, because Mac usually unzips automatically. Do you have Stata on your computer? Yeah. No, so then you won't be able to follow along. So you could watch along, but then yeah, you won't be able to follow along with the files.
Where will this be uploaded or uploaded?
So it is going to be placed on our website. I'll show that in a second. Yeah. Okay. Any other questions? Okay, so just go back. Just go to the tiny URL. Okay, so someone asked, where is this all going to live afterwards? So it's going to live on our website. At erc.barnard.edu. It will exist later on the workshops tab. And then there will be a fall 2024 section. I'll post your class. So if you click on that link, it will provide both a link to these files and then also a link to this recording once it's finished. Okay. Other things about the ERC while we're on the website is, so let's say you need some support as you are working on your assignments. You can come visit us. There's usually a help desk in this room staffed by our students. So if you click on the Visit Us tab, you'll be able to see times throughout the week that you can come and get support. And we try to make sure that there's quite a bit of support throughout the week and then also a little bit of support on the weekends. So you can feel free to come in. The only thing you'll have to do is make sure you check to see who has a Stata skill set. Because we provide support for a variety of programs, not just Stata. So later there is a skill set chart. It has to be updated, so there's a couple other fellows that have a Stata skill set as well. This will be updated soon. And then below it, you'll also be able to make appointments with our full-time staff or our grad fellows. So then later, for example, let's say for someone like Michaela, you'll be able to click and see possible times they can book an appointment with her. So the difference is with the appointments, they're kind of like set aside time periods they can book in advance, whereas the walk-in, it's more you can just come into the room and get some support. If there's a class, like there is like right now, this kind of workshop, then the hours are held right next door in Milstein 101A. Okay, any questions about getting help from the ERC? If it ever happens that none of the times work for you, not the ones in the walk-in desk or the appointment hours, you can feel free to email us at erc@barnard.edu, and then we'll see what we can do. We can see if we can schedule you in somewhere. Okay, so let's go back to the workshop and the files. So in here, we'll minimize everything else. In here, we have 4 different files. One WVS_subset is our data set. So it's an Excel file. If you hover over, you can see it's a CSV. This contains data from the World Values Survey. That's the data set we're going to be working with. Then there's a Word file. This just contains the same stuff that what's called our do file contains. It doesn't have any of the code, but it has all of the text surrounding it. So you're able to kind of have like this outline. Okay, and then lastly, we have 2 different do files. So we'll see what they are in a second once we open up Stata. So if everybody, for those of you who are following along, search for Stata and then open it up. It should look something like this. So first, with Stata, what you can write, they're called commands, and you can tell Stata what you want it to do. So usually one of the first commands that you use for any program, in this case, it's not going to be clear what it does because we're all working with pretty fresh copies of Stata. No one has really used the computers before right now. There's no data set that someone has like loaded in, but if there was, you'd want to clear it all out before you work with your own data. So that way, the computer doesn't end up making any mistakes if there are variables, let's say it's someone else's data set and your data set that have similar names. So usually one of the first commands, and you can write commands down here where it says command, is clear. And if you press clear and press enter, what it'll do is first, it'll show up in your history. And secondly, if there were any data sets, which you would see on the right-hand side, it would clear them out. Again, like I said, we're all working with pretty fresh. It's the beginning of the semester, so you're not really going to see any impact of the clear. Okay, so the next thing is, let's say you, like we do, we want to work with our data set. So Stata, the way it works, it's not really like Excel or anything where you kind of just like load in your data into it, and then that's it, it stays there and it's saved in there. what Stata and other programming languages need is they need to know where something exists. That's where they're gonna pull things from. Because if I write right here, for example, load in the WVS data set, it's not actually gonna know how to do that because originally where it's gonna look is just like at our base folder, which usually is just kind of like the home folder or the this PC folder right here. And obviously this is not where our data exists. So usually you have to tell something like Stata where your files exist. And the way we're gonna do that is we're gonna press File. And then we're gonna say change working directory. Okay, the working directory is the folder that it looks inside for any commands that you tell it to do. So things like reading in a data set or saving something. So we're gonna find our downloads and then we're gonna find our ERC Stata folder. And then you're going to click OK. And again, if you miss any steps at any point, please let me know and I don't mind repeating myself.
Give some help just downloading this folder.
Yeah.
Oh, yeah, sure. It might have been in the extraction. Okay, yeah, so wait, just go back. Go back, I think we just turned into a different. Put in the tiny one. Oh, here's.
This open.
Yeah, so and on the main page, if you just go back. There. Oh, you already downloaded
Yeah,
that?
we already
Okay, so then
downloaded
in
that
here-
and we have the next folder open,
Okay.
there's like one you said with the Stata on,
Yeah,
but we were trying to find the other.
yeah, so to find that, you're going to find your, just open up your computer. And press on file explorer. And go into your download folder. And yeah, click on that, you double click, and then boom, you should extract all button. Press extract. And then now.
Oh, it comes up on.
Yeah, now it'll
Okay.
come up, so if I press data, file, change working directory. Okay, so does everybody have that up? It's not showing up under downloads. Yeah, so that might have happened for some folks. So if it doesn't show up under downloads, what you want to do is here in your bottom, your docking bar, click on the file explorer. Navigate to downloads. And usually what happens is you didn't extract it. So find the file, the one that has the zipper icon on it. And you'll see it'll say compressed on it over here, double click. And then press extract all. Okay. Also, I don't mind side conversations, but the mic is pretty sensitive, so it might capture what you guys are saying. So just letting you all know. Okay, so now it should show up under downloads when you try to change the working directory. So what it did when you did that is it ran another command because Stata only works with commands. They just provide this interface for us to click through things, so it's a little bit easier to work through rather than always having to write out commands. So in this case, it's using the command called cd, which is just telling it to like change the directory that it's looking in, directory meaning folder, and it's telling it where to look. So this is one thing that I noticed that you know, the newer generation, because you all use phones a lot more, and also the way Mac kind of configures their folders is sometimes a little bit confusing, like how this structure should be written. So if you're on a Windows, if you ever sometimes have to end up writing it yourself, if you just double click here, or even sometimes with a single click, it will show you like the file structure. Okay, it's going into users, then students, then downloads, then into the ERC Stata. On a Mac, it's a little bit more confusing, but what you would usually do is you would right click on your folder, and obviously there's a window, so you're not going to see that option, but there's like a get info option, and that will also then show you what is that like tree structure of like what folder is it in over and over. Okay. So that's the command over here. And then now we want to pull in our data. So I'm not going to do that. Actually, let's just do that here. So we're going to click File, Import. And this part is important to make sure you know what your data is organized as. So if it's an Excel spreadsheet, you would click Excel spreadsheet. In our case, even though it had the Excel icon, it's a CSV. So we have to make sure we choose the second option, which is text data. And you can tell it's a CSV because in our folder, if you hover over it here, it says it's a comma separated values file. The other way to tell is if it says the extension. So if you're on a Mac, it would say something like wbs_subset.csv rather than .xlsx. Okay, so again, we're going to click File, Import, Text Data. All right, it's going to look something like this. And the first thing you're going to do is click on the little icon next to File to import. All the way on the right-hand side. And again, you're just going to find your ERC Stata folder and then click on WBS_subset. And press OK. Sorry, I have to press open first. Okay, it should end up looking something like this. You should see that it's being loaded into memory. And all the other defaults, you can leave them as they are. Again, how I got here, File, Import, Text Data. And then I clicked on the little icon and chose WBS_subset. Okay, and then we're going to click OK. But notice just before you do, there's lots of numbers in here. Even the variables are written as numbers, V6, V7, etc. There's some NAs, so there's missing values in our data set, so on and so forth. Usually that is what will happen, where a lot of your data that you'll load in will not actually have meaningful column names. They'll just be referred to with a combination of letters and numbers. And so usually you'll work with a metadata, what's called a metadata file. Metadata just means data about your data that tells you what those columns are. And usually your professor will provide you with that. Today, I'm just going to tell you which ones we're going to work with and what they represent. Okay. Great, we've imported it. And we are then able to work with it. All right, one thing I want to show you first is also what to do with what is called a DTA file, which is another type of data set that your professor will probably provide to you. That's a Stata data set. So if we were to have that, how would we work with it? So obviously right now in my folder, we don't have a DTA file. So what we're going to do is we're actually just going to save the file that we have as a DTA file. So we're going to click File, Save As. And then we'll just call it WBS here. And notice for save as type, it says Stata data. So it's a .dta. Why would you want to do this? So right now we haven't made any changes to our data set, so it's kind of redundant and unnecessary. But later on, let's say once you've analyzed your data set, you've made new columns, you've renamed columns, you don't want to have to rerun all of your commands again. If you save it as a Stata data set, next time you go, you can just load it in and then continue from there. Okay, so now let's press save. And if we now look in our folder, we can see that there is a wbs.dta file. So let's say now you have this file. How do you use that data set in memory instead? So that looks slightly different. So in that, instead of importing, you do file open. And then you find your DTA file and press open. Okay, so we're gonna do one more command and then we're gonna move to what's the do file. So the next command, we're just gonna write in browse. Like browsing a site. And what that will do is it will open up what's called this data editor. You're able to then see your data the way it would look in like Excel or some type of spreadsheet software. Okay, you can see the name of the variable, what it's labeled as, what the type is. So int means it's an integer. Byte usually means that then it's either a longer integer or it might be a decimal value. str2 stands for string. So that's usually means it's text data. And notice that's a little weird, right? So if you look at V4 here, if you're paying attention, it says string, which like I said, represents text. But V4 here only looks like numbers. So why might that have happened? That'll happen if you have, let's say, any NA in the column. Because NA is text, it doesn't know how to convert that to a number. So it just makes the whole column a text column. So even though to us this looks like numbers, 1, 2, 1, etc., to the computer it's text. So if you try to say to the computer like, or put these in order for me, like sort them, it won't be able to do it. Or give me a minimum, it won't be able to do it because it's treating this as text data. So we're gonna learn later how to convert it. Okay, but for now, just things for you to know. So let's close this window. So one of the things that's the issue in Excel is, let's say you're working with a team of people, and you're doing things in your, and for analyzing your data, you're changing up variables, so on and so forth. And now you need to share it with somebody else, right? And they're trying to figure out what you did, or maybe there's a mistake and now they need to fix it. A lot of times you don't know what someone did in Excel because there's no way to really see the history. You can't go back and figure things out, how they calculated things. Sometimes it's possible through the formulas, but not always. Let's say also you're working with a huge data set, a much bigger data set than you might, let's say, pull in Excel. And you don't want to have to redo lots of commands. Let's say something crashes, what do you do in those situations? So Stata uses something called a do file. So instead of writing our commands here, what we do is we write commands in that file, so it saves it for us. It's a file with all the commands that we ran. So if anybody needs to see what we did, they immediately just open it up. We can read through all the commands. Your professor for one of your assignments will probably provide you a do file, so you can see like, let's say for econ papers, they'll upload their do file so that people can see what they did. Because again, in academia, replication is really important so that people can then see like, how did they come to these results? Are they, can they be replicated by somebody else in a different experiment or a similar experiment? Okay, so to open up our do file, we're gonna say file, open. And there's two do files here. Normally what I do is I open up the one called workshop script where it doesn't have any of the code and it just has the information. And then we write the code together. Because we have a bigger class today and a lot of you are sharing computers, we'll actually just open up the answers file so we can see the code and then we'll just walk through what each of the lines does. Just to make it a little bit easier. So the one called workshop answers. So open that up. And now you will have two files. So you want to make sure that you move your windows over and resize them a little bit so that things are easier for you to see what's happening. And let me close this as well. So you should have two windows like this. This is called your do file, and then this is your Stata window. So things like what we just did, where setting a working directory, you can see that there are commands for that here. If you're working on the same computer over and over, you'll probably want to put that in. In my case, or in this case, you know, we might not want to put in like an exact location because obviously if you're going to go work on a different computer, it's going to be a different location. Right here, it's user, student, desktop. Your computer will have usually users, your name, and then desktop, etc. Okay. But let's say you ran something here while you were just testing things out and now you want to include in your do file. How can you do that? So we can just right click on a command, copy, and then just paste it in wherever into the do file. Notice also in the do file, there are some lines that are just green. those are comments in the file. So if you're writing anything that's not a Stata command, it has to have the star in front of it so that the Stata doesn't try to run those lines. If it tries to run something like Stata Workshop, obviously that's not a command, it's not gonna know what to do, it's going to stop running, it's gonna give you an error. Okay, so what we're gonna do, oh, go ahead.
It's telling, like, on the computer or whatever it's telling you to use like an app to. What option?
If it, so did you probably tried to open it from here, like from the file explorer, so that's why it's not sure what to open it with. You can navigate and find Stata, but the easier way is inside Stata, pressing file open and then clicking on the new file. Yeah. Okay, so what we're gonna do is we're actually gonna replace some of these lines. So for example, the CD line, just copy over your CD command and pop that over there. Mine look they look very similar, but they're just slightly different. And the import one. And save. And then the use. And why am I doing that? It's because when you run the commands in a do file, usually it'll just start from the top and continue running. And so if we had written desktop here, which is what was here originally, it's gonna look in desktop, it's not gonna find the file, and it's gonna stop running. As soon as it runs into a line, it doesn't know what to do with, it stops and just it'll continue to run. Yeah.
The history, or how did you get the history thing pop up?
Oh, so mine is a default, but if yours is not showing up, you can press window and then you can choose whichever things you want. So if you press window history, it should show history for you in the sidebar. Yeah. Okay, so everyone good so far? All right, because now we're gonna actually start working with the data. So the first command that we want to run is called tab. Tab creates what's called a frequency table, which just tells you how many times something appears in your column. So the tab command in V2. Actually, by the way, let me just zoom in, I guess, so that you're able to see this a little bit better. Sure, go ahead.
The import that like fill in the least first time. Takes that over what was already there.
Yeah, no, just paste it over what's already there. Yeah. All right, so now we're gonna run tab V2. So to run it, I'm just going to highlight it. And then next to the play button, I'm gonna click, I'm gonna click on tools. Okay, so again, highlight your line, tools, and then there's a line at the end that says execute selection, parentheses include. You can see that there's also a keyboard shortcut. So if you want to continue with the keyboard shortcut later, you can also do that. So I'm gonna press this. And then it is going to run my lines from the beginning, and then it is going to run this tab V2. So what is this table telling us? It's telling us that the V2 table has two values, 156 and 840. One of them shows up 2,300 times, one of them shows up 2,232. And what percent of the data? So 156 is a little over 50%, and then the other one is a little under 50%. So basically they're trying to get a equal distribution here. And then you also have the totals. Okay, so one of these is, in this case, what we're looking at is a data set on, we took a subset of the World Value Survey. People asked, there were some questions that people were asked. And so this is two of the countries, China, that's 156, and then 840 is the US. And we're just gonna analyze some of that data. So, okay, so first thing, right, you might not wanna work with it keep being called V2, so you know what it's called, it's a little easier to work with. So the first thing we're gonna do is we're going to rename this column. So to do that, you run rename, and then what it's currently called, and then what you want to call it. So rename V2 country. So again, I'm just gonna highlight this, and then tools, execute selection include. And now notice up here in variables, for V2, it says country instead of V2. All right, let's now tabulate this new variable that we created, tab country. And now I'm just gonna use the keyboard shortcut, Control Alt D. If you all wanna keep using the tools, execute selection, feel free. Just for the sake of time and to make it a little easier, I'm just gonna press Control Alt D. On a Mac, the shortcut might be a little different, so just see whatever it says before you press it. Okay, and let me delete this because it'll confuse you all. All right, so now when I tab country, it will tab that same variable for me. One other thing you might want to change is also this label here, where when the table gets formed, it still says V2. And that's because the label and name are two different things for each variable. And so we'll change the label in a second as well. Yeah, do you have a question?
I think it's some kind of error.
You're getting some kind of error? Okay, let me just see what's up. All right, so everybody, I want everybody to try running tab V2, like what we had called our variable before and see what happens. Oh, yeah, so it's like here, so you're gonna copy these over and replace it over or say that CD, so your CD come in and it's gonna replace it here, it looks like, but this one you didn't replace, so yeah, you can copy it over.
Same thing with all.
Yours is the same issue that the. Yes, I have it with
I literally have to or just.
So now things are usually showing, but where it says CD, copy that over into where it says CD. So if everybody ran tab B2, what result did you get? What happened? Oh, you have it. Yeah, go ahead. What does it say?
Oh, then I could browse that.
Yeah, okay, that's what's supposed to happen. Okay. Yes, exactly. All right, everyone. So did everybody run tab V2? It should have given you an error. Okay, and the reason it gives you an error is because now there is no variable called V2 anymore. We already renamed it. So you have to be really careful. As soon as you rename variables, you can't use that anymore in your code. Okay, so just a thing to be careful with. Because it trips a lot of people up. A lot of times people rename things, but then they refer to it as it was before. So you just have to be careful you don't do that. So for example, this line now, if I try to run all my code, it's going to cause an error because obviously we don't have V2. So if you have a line like this, make sure you put a star in front of it so it becomes a comment rather than stays in the code. Either delete it or make it into a comment so it doesn't give you an error later on. All right, and one other thing that we're gonna do now is what I said, where when we run tab country, it prints out the table that we want, but instead of it saying country over here, it says V2. So that step is to use the label command. So you're gonna say label the variable country, and it's just gonna label it as itself. So I'm gonna again press Control Alt D. And now if I run tab country again, it will now say country here instead of saying V2. Yeah. You have an error, what does the error say? It still says V2, did you run the label bar? Yeah. Yeah, just organize here. Just sit with that for a while.
It turns red.
Okay, and then now run the secret. Then now let's have that again.
Yeah, no, yours works. So if you were to run it, it works stop here.
Yeah, you're good, but just make sure you. All right, so the next step now is to change up the 156 and the 840 here. So again, if you're submitting tables for your report, your professor is able to then see what these things represent. So to change those labels, there's a couple of steps that it takes. So the first step is to define create a variable called country label in this case. So here we're telling it define a variable called country label. Let 156 correspond to China. And notice whenever there's text, it's in quotation marks. And then we say let 840 correspond to the US. And then what you do is you say label values for country, assign this label to it. So you just have to be careful with how you write these things. That new variable that you created is what gets added to the end of this label values command. So now you're saying first create this variable that links up 156 in China and 840 in US, and then make sure you update the values of country to use this label. And then tab country again just to see what happens. So I'm going to run all these three together. And now you can see it should say China and the US. Okay. We're going to do the same thing again for renaming this variable called B240 for gender. And then now when we run the tab command, we're actually going to run it with two variables, country and gender, so that you'll get what's called a cross tabulation. A cross tabulation is with two variables. So we see China and the US here, and we see the gender variable up here. So now you can see the breakdown not only by country, but also by gender. Yeah, the question in the back?
You know how you have in this, like, people, you had like double dots? I don't know how to explain it. There was
This right here?
Yes, and I feel like in one of them, if you could take a look, something is not.
No, that's fine. It doesn't matter. The dots don't matter. Yeah, it's just doing it by default. Yeah, so if yours, as long as yours still gives you the results, you're good. Yeah. So I just ran these two lines now. And in this case, gender, 1 is male and 2 is female. Okay, great. Now let's say we want to run that cross tab again, country and gender. And we also want percentages so we get an idea of how distributed the data set is. All you have to do is add a comma and then add row and column after your tab. And what that will do is it will give you percentages. So now the table looks a lot more complicated. And so it's easy to get overwhelmed, but just read through the key where it's the top is frequency. The second is row percentage and the third is column. So what row percentage means is that across the row, it'll add up to 100. So you can see it says 100 here, which just tells you within, let's say China, how many are male and how many are female percentage wise. And then column percentage means that this 50.95 and 49.05 add up to 100, looking along the column. Right, so it's very evenly distributed. You can see all of them are pretty equal to 50. That's not always going to be the case for your data set. So when you have uneven distributions, it's really important to be able to know, like, okay, my data set is very skewed one way or the other. Okay. All right, we're going to rename this other variable B160 and tab it. The question that people were asked here, what B160 is people are asked how acceptable or unacceptable do you think most people in your country, US or China, would find it if a suitably qualified 30-year-old was their boss. So essentially it's trying to see how people feel age distribution. There's going to be a question later asking about a different age boss. All right, and you can see it has values from 1 to 10 and NA. Does anybody see anything weird about the table? Not really a trick question, but what's weird about the table? Yeah, can you say a little louder?
Oh, the 10 is like not in order.
The 10 is out of place. So does anybody have any idea why that might have happened?
There's an NA. So then it's
Yeah, so I'm just gonna repeat what you said because people might not have been able to hear it, which is that because there was an NA, And as I said before, it would probably read it in as text, and so it doesn't know how to sort this column. Right, and so that's what's happening. The 10 is up there at the top because it's putting these things in alphabetical order, which is what you want when it's a text column. But in this case, it's just not a text column. It's numbers being represented as text. Okay, so we need to fix that so that we can then have this be in order. So first, let's just look at what's called the sum command, which summarizes the variable. Because that you'll see, usually in that case, you would see things like, and I'm just gonna widen my window and then run it again because the table is getting a little bit cut off, which is why it's printing weird. I'm just gonna widen this window and then run it again for you guys to see. Okay, so you can see that it's supposed to tell us observations, mean, min, max, etc. But again, because it's not a number, it's not doing that. So the next thing to run is codebook. You don't always have to run these things. I'm just showing you that if you're not sure what's going on or why things are out of order, what you might do. Right? The code book, what that does is it gives you more information about a variable. So again, here's where it tells you that it's a string variable. It tells us what are the unique values, and it also tells us how many things are missing. Right? So again, because it's treating it as a text variable, it also doesn't realize that NA means missing, which is why it says 0 are missing. Okay, so those are a couple of the things that we need to fix. The first thing that we need to do is we need to get rid of those NAs, and we need to make it into a format that the computer understands so that it can then convert the whole thing into a number column. So to do that, any place where it says NA, we're going to convert it into what's called the empty string, which is just quotation marks with nothing inside of them. So we're using this command here called replace. And what replace does is it says, and so commands, one thing to notice is they kind of like, they're not in like the logical order that you would think. And so sometimes you have to kind of move around to understand how it's saying. So this is saying replace anywhere where 30-year-old equals NA. And notice there's 2 equal signs. And that's because in programming languages, if you say 1 equal sign, you're saying you want to now make that variable equal to that new value. But if you want to just check if something equals to something else, you're going to use 2 equal signs. Okay, so we're going to say if 30-year-old equals NA, that's why you have the 2 equal signs here. And notice again the quotations. Then let 30-year-old equal this empty quote. So there's just quotation marks, nothing inside of them. If we run this, and then I'm just gonna add again a tab, sorry, not tab, yeah, actually, let's just do a tab, 30-year-old. Oops, I named it differently. If I run these 2 lines, now we can see it doesn't mention NA here. That's also one of the reasons, by the way, why you might want to run codebook, because once you get rid of NAs, you don't actually know how many are missing until you run codebook, and then it tells you how many are missing. Okay. So once you do that, now we can just convert the variable, because now for Stata, if it's the empty string, it knows that this means missing. So it's not going to have an issue converting any of these rest of these numbers into numbers. So to do that, you run the command dstring, the variable, and then we add a comma and say replace, saying just update the column and put it back into itself. So 30-year-old should still refer to this column rather than creating a new column that's the number and keeping the old column the text. Okay, now if I run this and then I run the sum command, it will give me, first it'll tell you all characters numeric, replace, how many missing values were generated, and then it will tell you, now the sum command will actually give you things like the mean, the standard deviation, the minimum, and the maximum, because now it understands it as a number. Any questions so far? Okay. Great. So now let's get into a little bit of charting. So something pretty simple, let's create a histogram first. So it's just the hist command. A lot of Stata commands are pretty kind of like self-explanatory. So hist. So it'll tell us how many bins, the start, and the width that it's created. And you can see now it has this histogram here. Okay, not the best histogram in this case, probably not the best. Oh, also, why did it it's supposed to create a histogram? Okay. not the best to look at this data set, so we probably want to change it up, right, and look at other types of plots. Okay. Lots of plots you can get here from this graphics menu if you don't want to write out the commands, because a lot of times it's not really gonna be just a straightforward like his. You might say, make the bar, make this many bars, or make the width of a bar certain, because obviously things change once you change up like the different settings. You might also wanna do things like add a chart title, change the axes, etc. So it might be easier to use the menu, graphics, and then choosing what you want. Let's say again, if you were to choose histogram, what variable you want. Oh, I guess in this case we had done 30-year-old. Here it is. How many bins you can choose here. So let's say if I only want, let's say 6 bins or something like that. So on and so forth. You can also set things like height labeled, and there's a bunch of other options here as well. And now if I click OK, what it will do is it will print out the new command, histogram 30-year-old, comma bin 6. So you can see as you start doing this, you'll start to get a grasp for how Stata, adds all these extra factors that you might want to change. And once, if you want to keep this later in your code, you can again, like I said, copy it and then just make sure you paste it so that you have track of what you created if you want to use it later. Okay, this is a much better histogram because it's actually not just 1 bar per item, which just look like a bar chart rather than a histogram. Okay, was there a question in the back?
No, sorry, I was
Okay.
curious how you got the bins to be fatter, but I think it's.
Oh, so the way I got the bins to be fatter is by choosing fewer bins. So when I did graphics and I chose histogram, here where it says bins, number of bins, the fewer bins you choose, the fatter they become in this case, because they're representing more data. Yeah. Mhm.
Why doesn't let me change the number of bins?
Did it like make you, once you check it, it doesn't let you check it?
Oh.
It's grayed out until you click on it and then you're able to update it. Because before it just does it by default, whatever it thinks is a good number. And sometimes its default is good and you want to keep it, but there are other times where you want to play around with it. And the other reason it's important to play around with this is because the number of bins can affect what the histogram looks like. And sometimes the histogram might appear to be skewed a certain way or look like certain means. And so you might want to play around with the bins a little bit first before you decide what goes into your paper or report. Okay. Now we're also going to work with another variable very similar to our 30-year-old variable. The difference with this one is that it's just asking people how acceptable do you find it if a suitably qualified 70-year-old was their boss. So now we're just going to do multiple steps at once. First, we're going to rename, then we're going to replace wherever it equals an A, and then destring. And remember, what does that do? What does destring do? Anybody remember when we just did it a little earlier?
Changes, the number that you make text to a number.
Yep, so just gonna repeat it, so everybody hears, just changes a number that's viewed as text into a number. So that way now maybe we can do things like see if on average, are people more likely to accept a 30-year-old boss versus a 70-year-old boss, and also dependent on country. So we're gonna run these lines. And then now we're gonna use a new command called tab stat. They're just different ways to get different summary statistics. So again, when we ran the sum command before, we did get summary statistic. And there's just another way to do that called tab stat. And we have 70-year-olds, comma, and then you write stat, and then in parentheses, which statistics you want. So in this case, we're saying we just want mean, and SD stands for standard deviation. If you wanted min or max, obviously you can add those in as well here. And that then just gives you the mean and the standard deviation. Why might you do this when you could just run this sum command on a variable? It just depends on how you're formatting your data for a report. Sometimes certain things are more important than others. And sometimes it's just easier not to confuse yourself with lots of different numbers. Maybe you just want those 2 stats, then just run those 2 stats. And we can see in this case for 70-year-old, the average is around a 6.8 and standard deviation is 2.2. Okay, and then why doesn't everybody now here do the same thing for the 30-year-old variable? Okay, so I'm just gonna let you do that, just take like 30 seconds or something. Right, so does anybody want to tell me what they ended up getting as the new mean? Okay, let's see, mean standard deviation. All right, so we can see the mean is pretty similar, 6.85, not that different in this case. A little bit higher. All right. We can also do things like analyze just subsets of the data. So maybe you only want to see the distribution if country equals China, for example. So tab a variable if country equals 156. Rules, execute, and we can see that distribution. And then if we wanted to, we could also rerun this to see the other distribution. And I'm just going to do that here for you. You can feel free to do as well if you want. Country equals 156. And if I run that, and now we can see the two tables, one above, one below, and see if there's any real difference between them. You could also then do if country equals 840 to see if there's a difference for the US. Okay. Something like that, where I said you could do first, let's say country equals 156, and then country equals 840 for the two different countries. You can actually just use then a command called by sort. And by sort, what it allows you to do is it allows you to run some command like tab separately for subsets depending on a variable. So what this is telling it is run tab 70-year-old first for one value of country, then run it for the next value of country. And notice it has a colon, just a little bit of a different syntax than what we've been seeing so far. And once you run that, notice first it says country equals China, and then it gives you the distribution, and then country equals US, and then the distribution. Okay. And if you're looking at this table, you can kind of already see that the distribution is a little bit different for the US. There is more lower numbers, right? Where this starts only getting higher once you get to the sixes, this gets pretty high from 3. So there's a lot more lower values in this data set. Okay. You know, these are some simplistic ways of getting to different summary statistics. Once you start playing around more, and also once you start seeing econ papers and how they do things, you're going to start seeing things that look like multi-line commands. So this is kind of getting a little bit to some of that, where it's saying use the tab stat command, 30-year-old and the 70-year-old variable, comma, give me these two statistics by, and then in parentheses, whatever variable you want to do it by. And then there's this thing that says no total. So let's just look at what this does. Right, so what this is doing is it's running that tab stat command. It's telling us first 30-year-old mean, and then the 70-year-old mean, the standard deviations also for China and then for the US. And the no total, what that does is, if you remember when we ran tab stat before, it sometimes also gave us the total number of responses. So in this case, it just gets rid of that. So this is like a simplistic table giving you an easy way to compare means for the two different countries. You can see that for both of them, it's higher for China. Okay. All right, what about creating new variables? That's something pretty common that you're gonna have to do in data sets. So to create a new variable, use the gen command. And we're gonna call the variable US. And we're gonna set it equal first to a period. And that's because for a numeric data set, missing what's considered missing is a period. Not like the empty quotes that we saw before, because empty quotes is what is considered missing for text variables. Okay, so initially we were working with a text variable, which is why we set it to double quotes empty. So usually you'll create an empty variable like this. So if I run this, and then I try to say tab US, there's really nothing because there's no observations. And then we're just going to use our replace command, which we know how to use. We're going to say let US equal 1 if country equals 840. And then just notice this next line, which is a little different from something we've seen so far, because this says replace US equals 0 if country, and then it says exclamation equals. So exclamation equals in programming languages means does not equal. All right, in this case, what you're saying is when it doesn't equal 840, then set it to 0. We could have easily also said if country equals 156, but that's because in our data set, there's only 2 values for country. But let's say you had a data set with 10 different countries. You're not going to then specify a whole list of what it could equal to. You can just easily say if it does not equal. And now what you've created is a binary variable that if you were to do some analysis, would be useful for you to use. You're going to work with binary variables, which means variables that only contain 1 or zeros, pretty often in your econometric analysis. Okay. Any questions again so far? All right, so now we're gonna do what's called recoding a variable. So recoding a variable is first, let's just run the first 2 lines here so we can see this age variable, and I just renamed it age. So you can see that you have this age variable, it goes from 18 to 93 in this case. Sometimes you want to stick with those types of columns, that's just a whole numerical spread. And sometimes what you want to do, because it's sometimes easier to see certain patterns, if it's a category variable. So if, let's say, instead of just being whatever age they are, instead it's telling you, okay, are they in like the 18 to 25 range or 25 35 or whatever ranges you decide makes sense for your analysis. Okay, so in this case, it was decided that those are the ranges you're going to use, 18, 25, 35, like those are going to be the breakpoints. So to do that, you could use the replace command, right? But it would take a lot of work because then you'd have to say replace anytime it says 19 with a certain value, 20 with a certain value, 21. You're not going to do that for all 93. So instead, what we're going to do is we're going to use this cut function. So here,egen, it works very similar to gen. The only difference is with gen, you kind of just specify the new variable you're creating and what it's equal to. Whereas with egen, you're specifying some function that's going to then affect what goes into that column. So here we're saying cut this age variable, comma, and where should it make the breakpoint? So then we just list out these different breakpoints inside the parentheses. One thing that to always keep in mind when you do things like this is what are called edge cases, which means, okay, if you're going to create new categories, right, where it's like 18 to 25 is the category, and then 25 to 35 is the category, where does 25 go? Does it go in the one below it or the one above it? Okay, so in this case, the way the cut variable works is it's always going to be included in the that second category. So 18 would be included in the first category, 25 in the second category, 35 in the third, so on and so forth. And then this is obviously just the end. Okay, so now we're going to run this and then we're going to tab that new variable. And you can replace these names because obviously now this is not just 18, this is 18 to 24. Okay, so you just want to make sure later you rename it, but this is how you create categories. All right, and doing this, we can see that it's slightly, it's pretty even, but there's slight skew just because there's much fewer younger folks in the data set. Okay. Other things you might want to do, create correlation tables. So that's just the core command, and then whatever variables you want to do it for. And again, then we can just run tools and run our line. And now you see correlations. So across the diagonal, you're always going to see a 1 because it's just asking how correlated something is to itself, which is always going to be 1. And then the other values will tell you then how correlated other variables are. Remember, 1 means it's highly correlated in the positive direction, meaning as one increases, the other increases. If it's -1, it means it's very correlated negatively, which means that as one increases, the other one decreases. And then you have obviously the whole range in between. Zeros kind of mean there's no real relationship between the two. And one really important thing is correlation doesn't mean causation. You may have heard that before. So just because it's correlated doesn't necessarily mean one is causing the other thing. Okay. All right, so we can see, for example, 30-year-old and 70-year-old are a little bit correlated, but not really that strongly. And then age doesn't really seem to be correlated at all, which is a little surprising. You would think that age would affect how someone's age might affect how they perceive what's acceptable or not. Okay, you can run regressions, which is something you guys will do a lot. You run the reg command to run a regression. So here we're saying run a regression. 30-year-old is my dependent variable and age is my age cat. The category is my independent. Actually, let's just run it first with just the age variable. So let's say reg 30-year-old age. Or you could just copy it and then delete the cat part. So let me run this. So in this case, our Y is 30-year-old and age is our X, right? Because you're saying, how does age affect this variable? You're gonna get a lot of results. I mean, I don't know how many of you have learned exactly how to read a table, but obviously you're gonna learn as well. But just things to obviously look at are things like the R squared. Usually the higher the better. It's not necessarily like a end all be all, but that is generally something people look at. You'll also then look at, this is your coefficient for age. So it's saying that as age increases by 1, 30-year-old appears to go down by -0.01. Other things to look at are also the p-values. Is this significant or not? And also you will want to look at your confidence intervals. So for example, if 0 falls in the interval, then that's not really a useful metric, because then that means it could be either positive or negative if 0 falls in your confidence interval. Okay, and then this is your constant variable. Right, obviously you'll learn in the class a little bit more about how to read through all of these things, but that's just like a summary. Then again, you could also do it on the age cat variable. And in this case, this is actually not doing the regression how it should, because our age cat variable right now is just these numbers. Whereas really the program we should replace this with text so that it understands that they're categories. So I'll show you what that would look like if it did think categories correctly. So for example, if we have, oh, we don't have a good variable like that actually. Let's see, so let's do reg, I'll do 30-year-old. I don't think it's gonna do it properly, but let's try reg 30-year-old. Let's just try a variable that we haven't really updated. So something like B3, no, it's not working properly. Give me a second. So this is not, I don't have a good example to show you guys right now, but if you had something that's what's called a category variable and is actually understood by the program as a category variable, what you would instead of, let's say something like in a lot of analyses, you might work with, let's say class, so you might have like lower middle income or lower middle, higher upper, whatever, etc. So then instead of just getting one coefficient, what you'll have is coefficients for each value that thing takes on. So you have a different coefficient for each of the categories. Okay. Great. You could also run regressions with a certain subset using if, so on and so forth. You could also add extra dependent variable control variables like this, so on and so forth. I'm not going to run those because we can just run them later and see how it is. And then again, one other plot, just again to see how you might create, let's say like a scatter plot. Again, this is written out for you, but you can always just go into graphics and start choosing the things that you want to make. You can see that there's lots of time series, contour plots, bar charts, dot charts, pie charts, box plot, lots of different things that you can create here. I'll just show you this one. be 240 not found. I think it's because we renamed this one 70-year-old, so let me just replace that here. And also here. Okay, and you'll see you got a chart. This is a very bad, what do you call it? This doesn't make sense as a pressure, even if it's two variables, so you always have to think what actually makes sense for me to do. The program will do whatever you tell it to do, but not everything makes sense conceptually. Because if you're working with a data set like this, you can see that obviously there's people that are gonna fall along every single value essentially, so it's pretty randomly distributed data set here. Okay, and then remember what I said before, where if you worked with a data set, you either could not do anything. And then that way, like when you get it back, you would just rerun this whole do file and it would get you back to where you are now, right? So that you don't have to rename the variables. All you would do is you would just choose tool and then just say execute do, and that will run the whole thing for you, and it'll get you to this point. Or what you could do is you could save this data set again at this point, and so then later you only need to load it in from here. Both options work. It just depends how big your data set is, because if the steps that you took a really long time, you definitely want to save it as a data set, so that way you don't have to then have the computer slowly run through all those things again. If it was pretty quick, I would just leave it, and then that way just always continuously work with the original data set. Okay. And one thing that's really important is, in this case, I give you a CSV, so nothing is gonna be replaced if I save the DTA file. But let's say your professor gives you a DTA file. When you save, make sure you don't replace your original file. Make sure you save it as something else. The something else that you save, you could always continuously replace. That's fine if you keep your commands here, but just don't replace your original file because you can't go back to what you had before, right? Your do file, you're also gonna wanna make sure you save, so make sure you just press file save. And then that way you have all the commands that you wrote saved. One thing that I see pretty often with people working with Stata is that they run their commands sometimes here because they're testing things out, things are not working. So this, it's a lot easier to just quickly run a command here and see what's happening rather than writing in your do file. But just make sure if you do that you always copy it over, otherwise you're gonna lose track of what order you ran things. You obviously have the history, so it kind of makes it easier. Excuse me. Yeah, so for example, notice if I ran clear, right, everything is gone, there's no more data here. So in that case, that's when I would want to do tools, execute do, and have it kind of rerun the whole thing. Notice you might have a situation like this, where it says save and it says already exists. So it will try to make sure that you don't make the mistake of rewriting things. So if there's a situation where you do want it to replace something that already exists, then you have to make sure to write comma replace. And if you don't want it to, then again, just make sure you comment it out so that it doesn't try to run that, okay? And then now, so on and so forth. And some other things that might happen, like this, where it says data set in memory has changed since last saved. So just make sure again that you're careful. Again, this saving and using were kind of superfluous because they didn't really change anything. We were just doing it for practice so you guys could see how it's run. And then now everything will run. As you can see, it's doing all of those steps that we did. And then it says end of do file. So that way, again, you don't lose any work. So always make sure you have the do file and make sure you send it to yourself if you're working on a computer that's not yours. All right, again, just one last thing. If you need any help, here are the walk-in hours, and again, you can book an appointment. I also have an appointment booking thing. Right now, there's no hours on there, but it'll be updated pretty soon, so you'll be able to book an appointment with me. So feel free to come get help from us, whether you have a short question or a long question, we're always happy to help. Thank you all.